Hello. Yes. Um, we welcome you back to PSSB, Physical Sciences Silver Bullet. It's me, Richard, here. Today we are exploring this question. Let us look at the question. It says the system below is moving at constant velocity of 2 meters per second. The coefficient of kinetic friction on the 6 kg and 3 kg is 0.48 and 0.3 respectively. Then it says calculate the magnitude of F being this pulling force. So this is what we are dealing with. We are having a 6 kg attached by an inelastic string to a 3 kg, which is being pulled by force F. Both bodies lying on inclined plane with angle of inclination of 25 degrees to the horizontal. Okay, how do you deal with this? Here, the best approach is to first deal with this 6 kg. Okay, what do we see here? We have our 6 kg and we look at its free body diagram. So when we analyze the forces which are acting, we can see that there is tension which is acting upwards due to the string attacked. What else do we know? We know that there is Fk, kinetic friction force, because we are given the coefficient of friction force. What else is there? We are having this force, the parallel component of the gravitational force, which is always acting downwards. What else do we know? Yeah, those are the one we have. So we are going to ignore the vertical forces because they are not contributive to this system in this case. From there, our next step is to apply Newton's second law. It says F net is equal to MA. But here we have to remember something. You have to remember that A is 0. Why? Because velocity is constant. So if that is the case, what can we conclude? We can conclude by saying that F net is equal to M times 0, which is equal to 0. Okay, from here, what do we do? Then you have to get your net force in terms of the functional forces. And we are going to say F net is equal to T cos 0 degrees, because it's in the direction of displacement, plus Fg parallel cos 180 degrees, because it's acting opposite to the direction of displacement, plus Fk cos 180 degrees. Okay, there we are. What do we do? From here, when you simplify, you are going to get F net is equal to T minus Fg parallel minus Fk. Okay, so from here we can substitute for net force, which is 0, and we set F net, which is 0, is equal to T, which we don't know, but we have to remember that the parallel component of gravitational force on incline is mg sine alpha. Okay, then we have also to remember, you have to remember that Fk is equal to mu k Fn. So here we're going to get mu k Fn on incline is mg cos alpha. When you substitute for figures, what do we get? We get 0 is equal to t minus m. What is the m? 6. Because we are dealing with the 6 kg. Okay, 6 times 9.8 sine 25 degrees minus mu on the 6 kg is 0.48 times mass, which is 6, times 9.8 sine 25 degrees. From here, what do? You get the figures, which is going to be 0 equals to t minus, let us get those values. So that is what we get. And from here, we can rearrange to get our t. Our t is going to be equal to 24.85 plus 25.58. You get your answer. Let's get the answer here. So there we are. We have our tension in the string, which is 53.43 newtons. But you have to remember that we are calculating force F, not tension. So what do we do? To proceed to the next step, it is imperative to use the 3 kg. And what do we do with the 3 kg? You have its free body diagram. Okay? Here we have our force F. Then you have other forces. Let us look at them. One is going to be Fk, by virtue that there is coefficient of kinetic friction. Next, we are going to have the parallel component of the gravitational force, which is always acting downwards. And what next? We are going to look at tension. So those are the forces which are going to need. So from there, what is our next step? Next is to apply Newton's law. Newton's second law is going to F net is equal to ma. But you have to remember that a is 0. So F net is going to be equal to 0. Then the next step, what are we going to say? We are going to have F net in terms of forces. So F net is equal to F, the applied force, cos 0 degrees, because it's along the direction of displacement. Then next, then plus T cos 180 degrees, because it is acting opposite to the direction of displacement, plus FG parallel cos 180 degrees for the same reason, plus FK cos 180 degrees. From there, what do? We can simplify and say F net is equal to F, which is our applied force, minus T minus FG parallel minus FK. Okay. From here, we can simplify for F net. F net, we know it's 0. So it's going to be 0 equals to F, which we are looking for, minus T. We have the T already here, which is 53.43. Okay. Then minus FG parallel, which is going to be mg sine alpha minus Fk, which is going to be mu k mg cos alpha. Okay, there we are. If you substitute for those values, we are going to get 0 equals to F minus 53.43 minus, what's the mass? The mass we are dealing with is 3 times 9.8 sine 25 degrees minus mu, which is going to be equal to 0.4. Let us put it here. It's going to be to 0 minus 0.48 times the mu on that one is 0.3, so mu is going to be 0.3, okay, times the mass is 3 times 9.8 cos 25. From here, you are going to get 0 equals to F minus 53.43 minus, let us get those values. So that is what we get. So from here, what do? You rearrange to get the applied force. So F is going to be equal to 53.43 plus 12.42 plus 7.99. What you get is going to be the applied force.